In this video, we will solve quadratic equations in one variable by factoring. A root of an equation is the solution to an equation. A quadratic equation can have 0, 1, or 2 roots. The roots of the quadratic equation are the x-intercepts, or the zeros of the related quadratic function. To find the roots of an equation, set the equation equal to 0. If the quadratic equation can be factored, the equation can be solved using the zero product property. Let's get some practice. Here, solve this equation by using the zero product property. So you can see that the equation is in factored form. In order for the product of an expression to equal 0, either one of the factors equals 0, or the other factor equals 0, or they both equal 0, right? And so now we solve these simple linear equations and we get that x equals 4 or x equals -5. Therefore, those are the two values that will make the quadratic equation 0. Our solution set then is -5 and 4. There are two roots to this quadratic equation which was in factored form. So let's solve this equation first by factoring it. We'll put our quadratic equation in standard form. The ax squared plus bx plus c equals 0. Now we'll factor that by using reverse FOIL. We'll set each one of these factors to 0. And we'll solve each equation for x. There are two roots in our solution set. They are -4 and 2. So when we're given a quadratic equation and we're asked to solve it, a good first step is to write it in standard form and then try to factor it. We'll try this again. So this is a quadratic equation because it has an x squared term, an x, and a constant. Let's first write it in standard form. And then let's use our box strategy to factor this quadratic equation. Recall in the box strategy, the quadratic term goes in the top left, the constant goes in the bottom right. Now we multiply these two terms together and we get -42x squared. And we start looking for factors of -42x squared, which will also add together to equal the linear term of -19x. Here's a pair of factors which multiply to equal -42x squared and add together to equal -19x. So they go along the diagonal. Now we look at our box and we think, what can I factor out of the top row? Let's factor out a 7x. Always try to factor out a positive from the top row. And then above 7x squared must go x, right, in order for those two to multiply together to equal 7x squared. And then we fill out the rest of the box. 7x times -3 is -21x. And x times 2 is 2x. So our two factors of the quadratic equation are shown on the outside of the box. X minus 3 times 7x plus 2. And just as before, we set each factor equal to 0 and we solve for x. Our solution set is, again, we have two roots, -2/7 and 3. So we solved that quadratic equation by factoring. That one was a little bit more challenging because the leading coefficient of the quadratic term was not 1. Okay, let's find the roots of this quadratic equation. Again, let's first write it in standard form. We'll keep our x squared term. On the left side, we'll bring over our linear term and bring over both constants. Now before I factor this, I notice that there is a common factor of -2 to all three terms. So if I factor out a -2, now my quadratic expression is much easier to factor. And here I can divide both sides by -2. When I apply the zero product property, something interesting, I notice that both of the factors are the same. Therefore, x equals 5 is the solution set. This is called a double root. The graphical picture of a double root, it will be a vertex on the x-axis at x equals 5. Finally, let's look at a problem-solving context of gardening. This is a typical context. The area of a rectangular garden is 51 square yards. The length is 14 yards more than the width, so let's call the width W. Since the length was compared to the width, the length is W plus 14. What are the length and width of the garden? So here's what we know about area of a rectangle. It's the product of the two dimensions, right? So W times W plus 14 equals 51. So at this point, you can either think of two numbers which multiply together to equal 51, if you can use mental math, but that's challenging for most people, so let's distribute our W into the expression. Let's subtract 51 from both sides. And let's use reverse FOIL and think what two numbers multiply to equal -51, but add together to equal 14. We'll set each factor to 0, and we'll solve for W. So whenever we are solving word problems that can be modeled by quadratics, a lot of times one of the solutions will be extraneous. It won't make sense in the context. And it does not make sense to have a negative width for the garden. So therefore, W equals 3. The width of the garden is 3 yards, and the length then will be 17 yards. So why don't you try a few problems here. Put the video on pause, go back and rewind and look at how we went about solving similar problems. When you're ready, you can resume and check your solutions. So here are your solutions to those 3 practice problems. How did you do?